Okay, well, it's 5 into the hour, so maybe I'll get started. Um, I guess first of all, thanks everybody for attending and showing some interest, and I hope everybody's staying safe out there, and that your family and friends and business colleagues are all well. Um, Also, I wanted to thank Northern Survey for facilitating this webinar Wednesday and for their offer, a gracious offer to have us participate in that. It's a pleasure, and hopefully the stuff we'll go through today will resonate and give some people some insight they might not otherwise have had. With respect to as I present, you can interrupt me if you want with a question, or you can type through the chat and I'll tee them up and cover them at the end of the presentation. If you want to ask a question during the presentation, just click your mic off and ask it. And if you want me to wait till the end, just log it in the chat, the Zoom chat group there, and then I'll go through all of them at the end, or if it's appropriate while I'm talking and I see the question, I'll just answer it on the fly. So with that, I'm going to share my screen here, and hopefully all the technology will be aligned. And okay, I think we're got action going on here. So I'm going to cover off CMS enables drones as per the material provided in the description of our presentation today. What I'm going to cover off is the platform itself, just to make sure everyone's comfortable with, that we're all talking about the same thing. How that equipment is operated in the context of survey and other applications of it, and then really focus on the bulk of, I think, the value proposition, which are things like capacity and even more importantly, moving sites to their full potential or maximizing cycle time. I think there's a number of ways that innovation superintendents are referring to the outcomes they're looking to achieve from any transformational technology. So I'll talk a little bit about what we've seen in terms of impacts of full potential. And I should note, and I'll probably comment on it throughout the presentation, that all of the information that I'm speaking to is the result of about 12, well, it's probably 16 months now of actual full-time operation underground. So it's not anecdotal from the perspective of, 100 service calls or 50 service calls. It's from over 150 operational flights as part of an ongoing operation underground. So that's sort of what I'll make sure we'll cover off. And I wanted to start with just sort of making sure we all are expecting or talking through the same thing. And in terms of drone-enabled CMS, we use a LiDAR technology. And what you see in the image that's on the screen right now is essentially our DB3 unit, and the sort of the magic of the technology is in the enclosure that you see mounted underneath the drone. So this is just a standard inspired flight drone that is constructed in an open platform so that we can essentially communicate and integrate all the various parts of the enclosure that are working together to create a unified solution. And in our particular case, we use two LiDAR, one that you see in the front there, and then there's another LiDAR mounted underneath to create a full 360-degree view, which captures about 600,000 data points per second, and allows us to really maximize the data points that we grab that generate the point cloud post-flight. You can see in some of the specs here on the side, just to give you an overview in terms of weight, it's just a little close to 6 kilograms. It fully illuminates itself. We do capture video on the way that's 1080p as the unit flies. I think some interesting facts on this particular unit are the fact that the point cloud, the end result, is generated on board the unit. There's no post-processing that the user has to apply or that we need you to buy from us or require support from our organization. So you can see the flight time is about 25 minutes, although you'll see in the balance of the material that, a typical stope or drift, if you fly more than a minute and 50 seconds or 3 minutes, you're doing something wrong, or it's you're getting tons and tons of data you don't need. So typically, the flight time and the flight range are more than adequate to fly in any stope or any drift situation, whether that's for survey or fall of ground assessment or any other incantation that you might want to apply the technology to. So essentially, it's very simple: drone, enclosure, LiDAR, cameras, lights. That is the platform that we're talking about. Now, in terms of operations, I'll launch a couple videos here as I chat, but the operation of the unit is relatively simple in that you sort of arrive, you assess your environment for safety, you ensure that it's safe to fly the unit in terms of loose debris on the ground, etc. Very, very basic kind of safety. You unpack, do your pre-flights, launch, fly whatever flight pattern that you've identified, land, pack up, and leave. And essentially, it's very, very straightforward protocol. And we typically teach our users, as well as apply to ourselves, a pre-flight planning and a mission planning protocol that ensures people are thinking through what they're doing long before they get there. So you see the video on my left, I guess be your left as well, is essentially accessing a very tight environment to create a super stope image. The point cloud you saw in color there is the post-processing drone-based point cloud. The solid you're seeing here is some sizzle we put on after the fact, is for the point of presentation. What you're seeing on the left is a typical drone flight. In this case, we did a double stope that was beyond line of sight. And you see down in the corner here, the small tablet is essentially allowing a mission specialist, a co-pilot, to monitor and help the pilot manage the flight, especially when it's beyond line of sight. So you see this particular flight takes us around a corner, then we come back and we go around another corner to essentially survey two stopes at the same time, as well as the access point, the drift, and then essentially we return and land, shooting the gap here too in terms of getting around some ventilation. And with respect to ventilation, other conditions, again, that's part of the pre-flight procedure, but not super complicated, not requiring a lot of overhead. And as I'll speak to in some of the other slides, I mean, this particular video is sort of under a minute. That's a real-time flight. I mean, it was a very large data capture, very extensive survey, and we were in and out of there in probably about 17 minutes. Now, if you take a look at the traditional protocols using OpTech units and traditional CMS units, just the configuration of tubes, bike wheels, and access points would probably take you in around 45 minutes to execute. And then obviously in that particular second double stope scan, it wouldn't have even been accessible using traditional technology. So, again, the main thing to take away from sort of this first element is the procedures are simple, the technology is fully integrated, and our focus is very much ease of use, because without that, you're not going to get the capacity benefits that we're going to talk about momentarily here. So what are the impacts of doing what you just saw? Obviously the first one, and the one that people gravitate most to, is the reduction in shadow and the removal for the most part. So you can see in the image that's here, that's sort of spinning on the screen, this is an actual stope scan we did. We did it with the OpTech unit, and then we did it again with the drone. And so you can see the red identifies what OpTech was able to capture, the traditional CMS unit, and then the blue represents the drone shadowing. And obviously there's a time factor that is involved here as well. So doing the traditional CMS scan was about a 45-minute exercise between wheels and pipes. The drone took us 13 minutes, and you can see there's a dramatic amount of data captured, and the full image of the stope is captured as part of that. So I think that if you then, I mean, all of the things that I'm talking about fundamentally have a foundation of increased safety. All of the work that we're doing is now, much further from the browse. Pretty much any area, any space that you can identify as a safe operating space. So you're safer and you're faster. And most importantly, you're capturing data that you otherwise either wouldn't be able to access or just wouldn't be visible just because of the nature of the technology that's being used. So, and those factors are really part of what influences the two big benefits of really what we've seen operationally, which is capacity and really changing the dynamic of reaching full potential, both in the cycle of, the standard mining cycle, the plan, the blast, the muck, the crush, the survey, the plan, the blast, that cycle. Part of this information starts to accelerate a number of elements in that cycle time or in that full potential model. So, to get to the sort of the root of the opportunity here and the sort of the thrust of this presentation, really, if you look at these things, you can now start to understand the implications and impacts on the capacity to perform the surveying role, which then has both downstream and upstream implications. So if you, as I mentioned, if you take a look at traditional CMS, even stationary LiDAR technology, you really in around the 45 minutes to an hour based, and it's with limited reach and range. And so that means if you're mucking, for example, you're taking that mucking activity and you're putting it on hold for an hour. When you use the new LiDAR technology that's drone enabled so that you have in motion LiDAR, which is sort of the real value proposition here, is that now you're talking, anywhere from 15 to 17 minutes to essentially execute, and you're getting all those shadows that you thought you were going to have to deal with are no longer there. So just from basic mathematics, you could see that, if I have a team and every stope they address is 45 minutes to an hour, and there's only so many of those windows of time that you can insert into, 8 hours underground or a 12-hour shift or however that survey team's being scheduled. Suddenly, if you say, well, now you can do 3 scans in the same time window that you used to do 1 survey, mathematics would dictate that your capacity is going to go up with no other change, no change in staffing and no change in any other of the procedures, and you've increased the safety element that those surveyors are exposed to. So you can see in the bottom of that slide is really talking to some of the benefits. And the chart that you see there is basically real numbers from 1 year's worth of survey monitoring. The previous blue line represents stope scans without drone technology, and the red line represents drone scans with drone technology, or CMS scans with drone technology. And the aggregate of that chart really is a doubling of the survey team's capacity. And based on the same active site that we're monitoring, they're looking to now triple what they did in 2018. So they're looking to go a double again on what they did the previous year. And a lot of that, what we're finding, is driven from the decision makers and the planners who now have an appetite and an expectation for no shadows and really high density in terms of data. It is worth mentioning that typical in-motion LiDAR solutions today have anywhere from a 3 to 7 centimeter variance, which isn't great if you're trying to do guide alignment in a shaft, but in terms of stopes and drifts and ground support inspections, it's more than adequate for the business requirements there. So you get this increased capacity just because it's faster. It's now safer. And the big thing in terms of capacity benefit is you can really change now the monitoring of the development. Where if you have a traditional CMS approach, you may, because of the overhead and the interruption to delivery, you may do those scans at the beginning of the development and at the end of the development to try and determine, you know, is my reconciliation on point? Did I get all of my deposit that I expected, or the ore body that I was after? Because now it's so quick and it doesn't interrupt to the same degree any of the processing activities of mucking and moving material. Organizations that we work with are now scanning 4 and 5 times to really closely monitor the recovery of the ore body and understand where there's opportunity to take more or not take too much, to so over blast, under blast, which contributes to better grams per ton at the end of the day. Which, as I've talked to some executives, that seems to be a hard thing for them to digest, that in fact, using drone technology can modify grams per ton and tons per day. But, and we haven't done any studies to actually prove or trace that. I mean, there's so many elements that factor into those two parameters that drive site operations. That'd be difficult to sort of pin it right to, hey, because you bought drone-enabled LiDAR, you know, here's the result you're getting. But I think what we can agree on is it's very easy to trace the capacity of the survey team to do more surveys in the same amount of time in a safer way. And because you can take a development now and monitor it 4 or 5 times without having an impact in a dramatic way to cycle time or full potential, it now changes the amount of data you're dealing with, which then drives many other elements towards full potential. So this is really, you know, when we, you know, the byline of this presentation, this whole capacity thing is really simply based on those two factors, that it's much faster and you get much more information, which allows you to do more. So from a capacity perspective, surveyors are doing a lot more scans and they're providing a lot more decision data to executives, planners, and engineers. And it doesn't have to just be on a new development. It can also be on a new heading. For example, we have a team right now, or a client right now, that's doing the scanning ore headings. They're using traditional stationary LiDAR. It takes them about 45 minutes in terms of positioning the scan and moving the unit, and scanning and moving the unit. They then have about 2.5 hours, give or take, to knit those scans together to create a full model that then feeds into monitoring the heading and the drill patterns, etc. If they take a drone and do that, our unit anyway, they could do it in 3 minutes, complete flight. And as they're on their way back to surface, the drone is doing all of the fabrication of the point clouds, so there's no post-processing required. So by the time they get to surface, there's a point cloud for them to feed into the planning and engineering phase of the cycle time. So tying that kind of thing together, we really can talk a little bit about full potential and now start to extrapolate the benefits that we've talked about here, that are really, you know, I get more productivity and more data from my survey team, more point cloud information, etc. The resulting activity means I'm scanning more frequently, and those scans have more data, which contributes to a couple key elements around full potential. One I've kind of mentioned, I think I'll talk about it in the next slide a little bit, but one is just getting surveyors out of the way, so, you know, mucking and trucking and crushing can continue to happen and are not delayed in any way. But the real value proposition that we're trying to study in conjunction with, you know, collaboration with our clients, is the implications around the spatial compliance and block models. You know, if you recognize that even if you're missing 10% of the scan data that's part of your development, and you feed that into your block model perpetually, that block model is going to be slightly off, and that error is going to compound itself time and time again as you make the same, you know, data adjustments and extrapolations that you have no other choice in making. If, however, now you had accurate data and that those models get tighter and tighter with each scan and with each collection of scans, and your block models are now more accurate, it now means that you're more than likely getting exactly the ore body you were after, which reduces your dilution, tightens up your reconciliation, which essentially is traceable to your bottom line. And that bottom line is the metric that demonstrates that you are at full potential. It's not a panacea of the solution. It is a component of the solution. But we really feel that this element, if you take, for example, improved data that's coming from survey using this technology, and you then blend that with improved blasting metrics or blasting technology, like the iRing solution that's out there, to make sure that you are maximizing, you're maintaining your direction to the ore body, and your fragmentation is maximized because you're blasting in a certain way. That blasting data comes from the stope scan that usually is from traditional methods. Those kinds of things then begin to compound and move you even closer to full potential. So it's really part of a tapestry solution, but I think that just on its own, it's hard to deny that better block modeling over time that compounds itself again and again means tighter models, which means more precise excavation of the exact ore body that you want, with better reconciliation, reduced dilution. And all of that block model then feeds into the decision process and the planning process that then feeds into the broader cycle of mining. So, I mean, I think that, just in sort of summary here, what we're talking about is faster capacity to actually survey, which ultimately means with the same people in the same amount of time, you can do more. Gathering more data that's higher quality, that removes shadows. Getting surveyors out of the way means the truck that could have been mucking, that's sitting idling for 45 minutes, is only idling for 15 minutes. That means they're mucking for 30 minutes more than they would every day on every stope. So if you think, how many tons could a mucker pull in 30 minutes, and you multiply that times the number of stopes you've got active, you can start to extrapolate to how many more tons per day you might get just because surveyors are in and out in 15 minutes instead of 45 minutes. If you add that then to improved block models over time that are getting tighter and tighter and more accurate and have less and less estimation to them, you begin to make better decisions and better recovery of the ore body. And all of those essentially really are, I think, delivering on the promise of digital transformation and the idea of moving closer to full potential mining through the technology. And that's it. Any questions, comments, rumors, gossip?
Hey, Mike, Miriam here. I had a few questions that I noted down. So one, you mentioned that the drone has a camera. Does it come with any sort of night vision or something of that sort?
Yeah, the camera isn't a standard camera. It's a specialty unit that's meant for low lighting. Now, we still wrap about 2,000 lumens around the unit itself. So when you look at those video, I don't think I did any FPV. I didn't include any first-person viewer perspectives. But you can see when it's flying in the drift that it looks like a ball of light moving around. The cameras are very low light, so you do get a lot of, in terms of the FPV control, the pilot's view, it is very clear. And the illumination then supports the low light, high def cameras that are on the unit, because our real desire and what we're working on now is moving to photogrammetry and adjusting the camera technology and the lighting technology so that we can use a smaller drone to get in those corners where the larger unit may not fit. So if you remember the spec, I think it was like 38 by 38 centimeters is the size of the drone, which may be a couple feet square tip to tip. But there are, in narrow vein, there are some instances where it's too tight and too much of a risk to risk the full unit, but a smaller drone would be perfect. And if we could get the quality of the imagery properly, which we're very close to, then we could just feed it in a photogrammetry, and now there is no crack or crevice that you couldn't do a point cloud for. But to answer your question, it is a low light camera, and it does illuminate quite well with the illumination we have on the drone, and the images are very usable. And we've done a few experiments with Pic4D that the point cloud from the photogrammetry has come out pretty close, but not good enough that it's ready for prime time yet.
Okay. And then the other question I had was, is there the option of seeing where your drone is inside your point cloud and then seeing the video side by side? So when you're looking at the video, you know what you're looking at within that scope?
Yeah, I mean, there is a, I mean, it doesn't, so yes, except we don't do, so there's two things that are possible. When you do a flight, there is a visualization that's produced immediately after the flight. It might take 5 or 10 minutes. That once you land shows you the actual flight pattern within the scope that you just, or the drift or wherever you've just scanned. So you can see essentially, okay, here's where I've flown. And we do that so that the pilot can validate, yes, that was a good flight pattern. And yes, I believe I captured all of the elements of the target area that I was interested in. One of the things that is, I think, unique or maybe a procedural parameter to this technology is that you must close the loop on the flight so that the technology understands the full flight path. And it also supports the georeferencing. That's part of what we do. So if you look at that flight path right after you do it, and you feel I didn't kind of go in deep enough or high enough, knowing that the LiDAR extends about 60 meters beyond the point of the drone, and there was a bench or an edge you wanted to get, you can look at that and essentially refly the mission. I mean, just another minute and 30 seconds maybe of time. And post-flight, we can also, based on the data that's there, map the flight of the drone and tie the point cloud with a virtual fly through, so you can sort of see the path and watch the drone as if you're on the back of it, fly the drift, so that you have, or the stope, so that you have some sensibility of where the drone is post-flight, like how it was flown and what it captured. Hope that answers your question.
Yeah. And then one thing that we have some trouble with is data. So is there the option of doing like a low resolution point cloud, less points?
Yes. Yes.
Yeah.
In fact,
Okay.
the application, the tab, so there's, I mean, the solution is a tablet application that has a GUI that you work with, and you essentially tell the drone, here's the sampling I want you to do. You can down sample as much as you want, and you can also pick the point cloud output that you're interested in. So, hey, do I want PTS and LAS? You know, we have, I think, 2 or 3 formats that are preloaded. But if a client says, I have a unique format that I feed into Deswick or whatever tool you're using, then we can adjust the software so that at the end of the flight, you basically, while you're on your way to the next scan or on your way to surface, say, oh, by the way, produce this point cloud with this level of downsampling in this format. And then by the time you get to the surface or to a safety bay where you can connect, you can upload the file.
Okay. Okay, great. Thanks so much.
No problem. A couple questions that have been messaged here. Have you ever lost or crashed a drone? Yes. 2 of them, in fact. And I guess fortunately or unfortunately, they were both from rock falls. Both were hit by, we were in larger stopes. And there was a release of some of the material. And unfortunately, it knocked the units out of the air. And they were actually recoverable. But I mean, they were in pretty decent shape, but when the mucker went to get them, it basically turned them into basically a crushed can of beer. So we have lost. We haven't lost anything due to pilot error or mechanical failure, fortunately. So our testing and Q&A has held up. Next question is, I'm not sure if you touched on this. How do you suggest georeferencing the scans to fit high confidence? Right. So on the georeferencing front, there's two ways we do that. We have reflective paddles that come with the unit. You basically mount those on the survey stations that might be at the brow point or the access point to where you're scanning. And we also, where that's not possible or that's not the protocol at site, we also use a BLK unit, stationary scanner, LiDAR, and we do the georeferencing with that scanner, and then we merge, the surveyors actually merge the BLK stationary geoscan with reference points on top of the reflective points that we might capture, because the LiDAR will reflect a painted number, anything that has a bounce back, and they then knit those two things together to create the georeference. It really depends on what the site wants. Most of the time, we just use the reflective paddles, and they create a hotspot in the point cloud that then is referenceable into the broader model, and that's how we tie it in. What is your commercial model? What is your commercial model? In terms of the what we sell to the market is the DB3, and we're using ousters. I mean, there's a whole bunch of best-in-class technology that we've woven together. We've made sure our drone platform is open. I think one of the challenges, we were using a DJI unit early on, but then to actually get to the flight controller to make it do all kinds of magical things and position it for scaling in the future to be a highly sophisticated, intelligent unit, we would have had to rely on the folks in China and the DJI community there to give us access or do the access for us to flight controllers and core intelligent function. So we basically moved to an open platform, North American made unit. And our, I see what you're saying, service. So we do both service and sales. Typically, we will serve any client that calls us. We have a protocol for that in terms of mission planning, et cetera. And we also, what happens sometimes is after a couple of missions, people want to buy and adapt the product once they see that it's relatively simple to use, only takes a few days of training and you're good to go. So we have both a product sales and a service model, whatever the client feels gives them the most financial value. Yes, there are pilot assist options. We're very mindful of the pilot assist functions because we're also concerned that full automation where the pilot has no real control has its own safety requirements in terms of if you look at automated muckers, operators have to be back and around and protected fully just in case the automation fails. We really focus more on a pilot assist mode, which is obstacle avoidance and basic hover. The videos you saw were in a hover format where once you set, you essentially, I mean, I've used hover. I'm old. I'm not a pilot. I don't fly regularly, but essentially once the hover feature is enabled, elevate it to a level of stationary level, and then it's set in the unit using the LiDAR and the SLAM on board to essentially maintain that unit. And then it's really driving on a single stick as opposed to like a helicopter where you're balancing 4 different dimensions. So that makes it easier to use. So we do have those options. If so, will it detect wire hanging from the back? Yeah, the challenge is that those almost invisible elements, we're right now, so will it detect it? Short answer, I'm not sure. We are trying to tune in the fidelity of obstacle avoidance right now. Stay tuned. Can you use the scanner without? Yes. So our unit, the DB3, is actually, and we're just sort of finalizing the marketing materials and positioning on this, but the DB3 is a triple threat unit. The enclosure snaps out, slides on a rail, snaps off the rail, and can be used in a handheld format. You could throw it in the back of a truck or on the hood of a truck, drive it around. You could walk around with it. In fact, I think they're doing some long haul measurements with a walk around today. And the other thing you can do with our unit is you can just take it on surface, apply a new profile, and use it as a surface unit. And we're just tightening up our photogrammetry capabilities on surface, but you can use it as a GPS denied or handheld unit. So yeah. Yeah, that's all true. And we do sell the handheld unit on its own. So if you don't want to buy a drone and you just want to walk around, that's possible. Can you export to DFX? Yes, you can export to DXF format. That's, I think, one of the 3 that we have as a default that you just select as part of the app. Any issues with map accuracy and performance issues in dust areas? No issues with dust, moisture, heat, humidity. We've been through probably the worst of the worst in those areas. Map accuracy, as I mentioned, is really just more of the standard variance in motion in LiDAR in motion, which is 5 to 7, 3 to 7. It really depends on the situation. Does the drone onboard software build any type of shield around the drone, which will protect it against flight collision? Yeah, that's part of what the obstacle avoidance is. So we right now have 2-dimensional avoidance. We're moving to 3-dimensional, so if you could imagine a full LiDAR bubble around the unit, and what we're trying to do now is tune in the fidelity of that bubble so that it does not jerk when it goes to avoid, and that you can essentially tighten it up to make sure that there is a clear sort of circular ring of protection around the unit as you fly it. All of those things are really our focus of continuous improvement around ease of use. I tell our engineers I have to be able to use it with 0 to no training, and I'm not using it every day or every other day. Last time I flew our unit was maybe 4 months ago. So it has to be a unit that you could pick up, and it would almost sort of be kind of like a surface drone. Not that surface flight is, that's not a diss against folks who fly on the surface. It's just that there are assist elements there that still put you in full control, so that at any time you can kill the unit and have full command for safety and protection, but that it is giving you feedback and assisting you with flight in terms of the fidelity of avoiding things, and the ability to stay stationary, so that if you're unsure of what to do, you can just tell the unit, just stay where you are for a minute. I need to collect myself, or I need to determine my strategy for the situation I've gotten myself into. Also, while giving real time, so does the drone have onboard software? Yes, shield. Also giving real-time readout of your distance on incoming objects, say on your tablet. I have to double check. I don't think I think the distancing metrics, sort of the parameters on the tablet, is what we're just finishing up development on. I think it is in QA and test right now, but I do remember my last briefing was around a bit of a dashboard on the obstacle avoidance that would give people that information. So our readouts and involving color and distance to help them understand how close they were to things. So it is probably going to be in the next, that sort of full capability will be in the next release. We typically deploy on a monthly basis upgrades, or as required based on customer demand to fit their particular delivery needs. One of the things that we've learned over time is that one of the most important things we have to consider as a company is never introducing a process or a technology that changes the cadence of mining, so that there is a cycle or a flow to the process, and we either have to reduce it or maintain that flow. Anything that we do that creates an extra step or takes extra time, we view as a sort of an unacceptable product feature kind of a thing, or lack thereof feature. So we are constantly trying to make sure that where our in use, I think we might be closing in on 175 flights underground. And as that happens daily, every operational situation you could come up with seems to come our way. We look at that and say, okay, well, are there things that we can do immediately that would improve the flow time, the standard operating procedure, to improve cycle time? And so part of our unit is connectable remotely, and once you buy the product, all upgrades and revisions and improvements are part of your regular maintenance, so that there's no cost to that. We essentially work with our prime contacts at site and ensure that upgrades and release notes are provided along with sort of the benefits of that. So while we try and do big releases and big improvements on a monthly or quarterly basis, we're constantly also taking client feedback, our own rigorous testing, and applying modifications and updates as required, and as the drone is made available to us by the sites that are using it.
That was a great presentation, Mike. I really appreciate you jumping on our webinar Wednesdays. It was, oh, we got another question. If the unit needed repairs, where would the repairs take place?
Oh yeah, so the repairs are done here in North Bay. And part of our service model, so one of the things that we really focus on, or have tried to focus on, is service level management, client relationship. So part of our service level agreement post purchase is a swap in, swap out agreement. We always have a unit on standby that is green tagged, which means that it's good to go. It's ready for use. So if you do have an out of service unit and that's impacting your cycle time or your full potential, we'll actually give you a replacement unit, take your unit in, assess, repair, and swap it back to you, so that that we minimize any interruption. But the maintenance and management, fabrication, manufacturing, integration, everything is done here in North Bay and in Northern Ontario, and we use as much Canadian content and Canadian suppliers as we possibly can. If you roll out the object avoidance option, oh yeah, no, we avoid ever having to charge you to purchase something new. For example, our initial units use the Velodyne pucks as the LiDAR units, which have 16 lasers. I think the Ousters we're using now have 32. If you, we essentially just twist off the old ones and put on the new ones. We did not charge our clients to do that swap out. We took the old Velodynes back and basically gave them the new Ousters with more data, better point cloud. So we are never looking to create a commercial model where it's like, we've got new toys, but it's going to cost you a fortune, or you have to replace in an expensive way. Our whole technology framework is based on a plug and play scenario, so that it is super inexpensive for clients, or it's at no cost or low cost, I guess is the way to say it, to upgrade to our next innovation. And that's the beauty of waiting for the leaders in the market to innovate on something, and then just being able to swap out the latest camera, the latest lighting, the latest battery, the latest LiDAR. Our focus is really on the integration software and the magic of creating immediate point clouds. If you could imagine, that's where the future is. Our business model is not a upgrade on, we're not dealing with leasing cars where we're looking for you to upgrade and make money on that. We think the value is in our innovation services and getting you to have us not only support you from a drone perspective. We have 10 other products that are meant to facilitate full cycle, full potential when a drone just doesn't do the trick, like some of our other Traxxas units, etc., that are really meant to get the data. We always get our man, so to speak. Do you rent out this unit for a client to try his demo? So we will come and demo. We've never done a rent out. I mean, we're not at a point now where it's like buying a GPS-enabled drone where you can kind of buy it and figure it out without sort of some training. You have to remember that there's a certain amount of digital literacy that's required. And I think, what we're learning on the whole digital transformation front is that there is a need for the industry to recognize digital literacy as a supporting competency to go with digital transformation. So we have not done a rental, but we are, there's two things that I think that are important about us. We believe in sharing the risk. So we'll do whatever we think it works for the client and us to mutually share the risk of dipping your toe in the drone enabled LiDAR water. And that may be sharing time or cost or doing something for you at no cost to help you understand confidence in what we're producing. And so, we're open to all manner of proposal. I wouldn't be comfortable on sort of charging somebody rent and sending them the unit in hopes that they can figure out how to use it and get the maximum understanding of demo. We'd much rather sort of, we're actually building virtual demos right now by working with some of our clients to sort of film the thing in action and the results in real time so that we could kind of virtually demo. But hopefully soon quarantine will be a thing of the past and we'll be able to safely visit and demo for people. I may have missed this. Can you miss private LT? Yeah, so we don't, I mean, I might not be as up to date on this on the LT front, but the drone is a Wi-Fi unit. It is a hotspot. It is based on a Wi-Fi protocol. And one of the things we're trying to work on right now, and we're hoping to work with some of the latest innovations like the Radiant breadcrumb technology, is to sort of put the drone on the Wi-Fi, on the network. And wouldn't it be great if post-flight, the point cloud automatically appeared on a server in the on surface for the engineers and planners to immediately start to work with or integrate into CAD or Deswick or whatever you happen to be using. So we're looking at and we're trying to find partners that can help us experiment. We have a client who is, hey, let's create an environment and a number of sort of backbone technologies from a network perspective, and let's work with trying to move towards I fly the drone in a stope or a raise or a fall of ground, and the moment I land, the data's already been, it's real time saving to a server that it has access protocols for. Our challenge is, I think you're noting there, is latency and capacity of the network. That's what we're looking to experiment with. Because if we can do that, then there's no reason I can't fly the stope from my chair right here if the backbone is strong enough. I participated in the digital transformation in the government sector to e-government and in the health sector to e-health in Ontario and abroad. And fundamentally, all the great solutions that were coming out really boiled down to the infrastructure and the capacity of the network. And that's, I think, where mining is at or getting to very quickly. If you can facilitate us doing some experiments on an LTE environment or any other protocols that are being discussed, we'd love that. Like, again, we like to share the risk and share the opportunity and collaborate on experimentation, as long as the client, like us, believes in continuously improving and rebounding from what doesn't work to something that does work. Then it's an ideal relationship. And I think it's a great opportunity. And I believe it's the only way for real digital transformation to occur is if there is a partnership that's based on results, not money, where we share the risk with each other to make things happen. I think one of our clients said it best: we never expect to strike gold on the first drill or the first sampling. So we should be able to embrace the fact that it may take us a couple tries to reach perfection on things like surface controlled drones and fully enabled networked utility drones like this to control from surface and store on surface immediately. So we do shafts, and we have done shafts. The challenge is guide alignment and the fidelity of the scan. So as long as the shaft scan is okay, and we're actually now getting feedback from work that we've done that's like, hey, you know what? That variance is good enough for being able to assess shaft condition on a monthly basis, but we'll need super high fidelity at least once or twice a year to do things like guide alignment and whatnot. But we have done shafts, and we've done them by sets, and we've done like a 3,000 footer. And the data is impressive and the imagery is impressive, and we do it in full 360, so you can put on the Oculus goggles and actually spin yourself around inside the shaft as the unit descends and ascends. So I think that we now have a solution where we can do a millimeter, I think it's a millimeter accuracy, which takes about a full shift. Whereas an in-motion scan that allows for the 3 to 7 centimeter worth of variance, we can do it about an hour and a half. So you can see sort of the benefit of being able to take over the shaft for an hour and a half and give video and LiDAR and with variance versus once a year taking a shift or two to make sure that we're doing a high fidelity for guide alignment and other sort of shaft maintenance activities.
He also mentioned that, are you able to map vent raises for millimeter accuracy? What would you have to say?
Millimeter would be tough on a vent raise just because the in-motion LiDAR is limited. Right now, it's not us. Is that technology? The only way to get that close is the Leica, is a 350 or whatever, that stationary unit that is super accurate, that does duo photogrammetry and LiDAR scanning all at the same time. The only problem is you have to move it along. So if you take a drone and you fly it through a vent, a pass, or any sort of concoction like that, then you're limited to the sophistication of the technology. So we're hopeful that Ousters and others, and we're looking at right now some mathematical models to try and take the information, the point cloud information, which we've done some experimentation where we've taken a high def Leica stationary laser scan, overlaid that on top of a drone flight laser scan of the exact same area, and the actual scans are within the same boundaries. So the millimeter accuracy is the data points of the drone flight actually overlay on top of those, and that tells us that the point data, the actual bang on data, is in that thick line that the drone's producing. The question is the statistical model of that data Gaussian, and can we find an algorithm that then finds the mean of all of those points to actually, from a software perspective, identify the exact range? And that's a research project that we're trying to get started with a couple local and non-local universities in the mathematics departments to see if we could collaborate to create a sophisticated math model that would then take the data and even though the LiDAR can't do it, it is capturing the accurate points in amongst the not accurate points. So we're hoping to get to a millimeter type accuracy that we can use in shafts and raises with the drone, and that we can do in quick time. So if you could imagine every shaft assessment only taking an hour or 3 hours, that has a dramatic impact to today's world, which may take several shifts to complete, and is a manual process that puts people at risk and in harm's way, so to speak. So I hope that covers that.
Awesome. I think if that's the end of the questions, Mike, again, thanks for taking your time to jump on the call today. We really appreciate the new partnership that we have. We're excited to get out to our network and for you to spend the time with us to get us out there. So thank you once again.
Appreciate it. Thanks for including us. And I really appreciate everybody joining and the great questions. And I hope everybody stays safe and has a great week.